What's up everyone, welcome back. Patrick here, moving on to the next video, still dealing with quadratics. So what we have to do for each of these quadratics here, we have to find the x-intercepts using the quadratic formula, and then we have to sketch each quadratic and label the vertex and the intercepts. Now, as a quick review, when we're finding the x-intercepts of a quadratic, or of anything for that matter, whether it's a line, a quadratic, or whatever, how do we do that? Well, notice that if it's going to go through the x-axis, which is where an x-intercept would be located, the y value would be 0. And so that's what we always plug in to whatever equation that we're given. So we'd plug in 0 for y, and then we would solve for x that makes that y value 0. And that would give us whatever x-intercepts that particular function that we're working with would have. So if we start off with part A, we're going to plug in 0 for y. And so notice now we have a quadratic equation right here. And whenever, just as a quick review, whenever we have a quadratic equation in the form ax squared plus bx plus c is equal to 0, the solution to that, the quadratic formula, would end up being that right there. Okay, so notice that in this case, the a value is 6, the b value is -17, and then the c value is -3. So plugging in these parameters for this formula, we'd have negative b, so -17, plus or minus -17 squared minus 4 times the a value is 6 times the c value of -3. And that's going to be all over 2 times 6, like that. So then we'd have 17 plus or minus -17 squared would give us 289. And then we'd have -4 times 6, which is -24, times -3 would give us positive 72, like that. And that's going to be all over 12. So then we have 17 plus or minus. Over here, this would give us 361. That's going to be over 12. And then the square root of 361 would be 19. And that's going to be over 12, like that. So notice there are going to be two solutions in this case, either x equals 17 plus 19 over 12, or x equals 17 minus 19 over 12, like that. So this would give us, what, 36 over 12, which would give us 3. And then this over here would give us -2 over 12, which would give us -1 over 6, like that. So those right there would be your two x-intercepts. So the coordinates would be 3 and a y value of 0, and then we'd have -1 over 6 and a y value of 0 as well. And then because we got these smooth values here, an integer and then a smooth fraction with no radical expression, it actually means that this, if you wanted to, it actually factors. So this, I think it factors into what, x plus 1 and then x minus 3, like that. Right? And then from those factors, you can get those same two intercepts right there. Okay, but again, we had to do it with the quadratic formula. We're going to be practicing using the quadratic formula. And quadratics are not always going to factor, but this one in particular does factor if you wanted to do it that way. Okay, so those are the two intercepts. And then if we have the two intercepts, we could also find the vertex. There's multiple ways to find the vertex. Remember, if we have a quadratic, just as a quick review, actually let's put these reviews over here. So if we have a quadratic in this format, remember the x value of the vertex, or the axis of symmetry, it's always going to be -b over 2a. That's a formula that you can always use. So multiple ways to do it. Your teacher may or may not introduce this formula. They may allow you to use it. If they do, then we could tell that the x value of the vertex, or the axis of symmetry, is going to be negative 17 over 2 times that a value 6, which would give us 17 over 12. So let's write that over here. So the vertex, we would have 17 over 12, like that. Now, if you don't do it this way, if you were to just use it, if you were to just find the midpoint of the two intercepts, right, that's another way to do it. So we would add those two intercepts and then divide it by 2, which would be like 18 over 6 plus 1, or sorry, plus negative 1 over 6 right here. So then the plus minus would turn into a minus. This would be over 2, so we'd have 17 over 6 divided by 2, which would give us that same value of 17 over 12. Okay, so this formula, maybe your teacher doesn't allow you to use it, but you can use it as a nice quick check to make sure that you're doing this algebra here correctly, where you're finding the midpoint between the intercepts in order to get that axis of symmetry. So 17 over 12 would end up being the x value of the vertex. And then if you wanted to get the corresponding y value of the vertex, well, we would just plug in that 17 over 12 into the actual quadratic and then solve for that y value. And if you do all of that algebra, I wrote it out over here just because it was going to take quite a bit of time. So over here, the 6 goes into the 144 24 times. So that's where I got the 24 here. Then we end up with those terms. Get the common denominator. You end up with negative 361 over 24. So that would be the y value of the vertex. Now, if you don't want to work with fractions, you could also convert these to decimals. So 17 over 12, that would be approximately like 1.4. And then negative 361 over 24, that would be approximately like negative 15.04. Just if you want to use decimals to see where it goes on the graph a little bit more clearly. So now we have enough information. We have the vertex, and we have the two intercepts that we found with the quadratic formula to make a fairly accurate sketch. This is not going to be to scale, but I'm going to label these points 3 and 0. This would be negative 1 over 6 and 0. And then we have a vertex at 1.4, negative 15. So that's going to be like down here. And then I'm going to label the vertex with the actual fractions there that we got, just in case your teacher wants specific values. We could also get the y-intercept, which in standard form, remember, it's just going to be the c value. For the y-intercept, we plug in 0 for x. We'd just be left with a negative 3. So that would be like over here. So we'd have 0 and negative 3. So it makes sense that if the vertex is here, and then the intercepts, the x-intercepts are here, that the y-intercept is going to be somewhere here. It's going to have to go through like that. So when we join these points, we end up with a quadratic approximately like that. Okay, so that's the process that we're going to be going through for all of these. So let's move on to the next one. Again, how do we find the intercepts, the x-intercepts? Well, we plug in 0 for y. So we'll have 0 equals 3x squared minus 2x minus 8 like that. So the a value is 3, the b value is negative 2, the c value is negative 8, and then we plug in those parameters into the formula. So we'll have x equals negative 2 plus or minus negative 2 squared minus 4 times the a value of 3 times the c value of negative 8. That's going to be all over 2 times that a value of 3, like that. So we'd have 2 plus or minus 4, and then this would end up being what? Negative 12 times negative 8 would give us positive 96, like that. This is going to be all over 6. So what do we get? 2 plus or minus root 100 over 6. 2 plus or minus 10 over 6. Like that, right? Because root 100 is equal to 10. So then, notice there's going to be two solutions here. So x can either be 2 plus 10 over 6, and x equals 2 minus 10 over 6 equals 12 over 6, and this equals negative 8 over 6, and this is 2, and then this is negative 4 over 3, like that. So those end up being the two x-intercepts. So let's keep track of these up here. So the two x-intercepts are going to be 2 and 0, negative 4 over 3 and 0. Now if we want to find the x value of the vertex, what can we do? Well, we could add these two, or the axis of symmetry. We could add them and then divide by 2, which would be like, this would be like what, 6 over 3 minus 4 over 3 over 2, which would give us 2 over 3 divided by 2, which is like 2 over 3 times 1 over 2, which would give us 1 over 3, like that. Just give me a sec, let me, yes, looks correct to me. So 1 over 3 would be the x value of the vertex. Now we could quickly check that with that formula that I mentioned over here where we have negative b over 2a. Your teacher may or may not allow you to use it, but if we were to check it, notice negative 2 over 2 times the a value of 3, which would give us 2 over 6, which does indeed give us that 1 over 3. So whichever way you do it, whether you find the midpoint of the intercepts or you use this formula, if you want, you could also complete the square. You'd be working with a lot of fractions though, so I don't recommend going down that route. What's nice about completing the square is you'll get the y value of the vertex right away as well. But either way, the x value of the vertex is 1 over 3. Now if we want to get the corresponding y value, we plug in that 1 over 3 for the x values. And so what would happen here? We'd have 3, 1 over 9 minus 2 over 3 minus 8. 3 over 9, that would be 1 over 3 minus 2 over 3 minus, if we change this to be a denominator of 3, we'd have 24 over 3. So we'd end up with negative 1 over 3 minus 24 over 3, which would give us negative 25 over 3. So that right there would be the vertex. And then if you wanted to convert these to a decimal, it would be approximately what, 0.33 and then negative 8.33, like that. And then the y-intercept would be 0 and negative 8, like that, if we plugged in 0 for the x values. So lots of information here to make a fairly accurate graph. We'll have 2 and 0 over here. We'll have negative 4 over 3 and 0. We'll have 0.33, negative 8.33, so that would be like down here. So let's keep it in fractions. 1 over 3, negative 25 over 3. And then we got 0, negative 8, which would be like right there. Right, so connecting these, we end up with a quadratic like that. Moving on to part C, so we have this next quadratic again, finding the x-intercepts. We plug in 0 for y. And so A is negative 5, B is negative 1, C is 7. Plugging in these values into the formula, we'll have x equals negative 1 plus or minus negative 1 squared minus 4 times negative 5 times the c value of 7, like this, all over 2 times the a value of negative 5, which would give us 1 plus or minus 1. This would be negative 4 times negative 5 would give us 20, times 7 would give us 140, and that's going to be over negative 10, like that. So then continuing this on, we'd have 1 plus or minus root 141, like that, and then it's going to be over negative 10. So there's going to be, by the way, this root 141, you can't simplify that radical any further. In the previous videos, when we've done quadratic formulas, sometimes I said your teacher may require you to go from, like, let's say root 8 to simplify that to root 4 root 2, which would be 2 root 2. But in this case, this root 141, 141 doesn't divide by a rootable number. It doesn't divide by 4, doesn't divide by 9, 16, 25, 36, etc., etc. So that is the final answer in as exact values. I'm going to get the decimals though, so x can either be 1 plus root 141 over negative 10, or x can be 1 minus root 141, and that's going to be over negative 10, like that. And then the two decimal values over here, we'd get negative 1.28, and then over here we'd get positive 1.08, like that. Right, so those are the two x-intercepts as decimals, and I rounded these decimals as well. So let's keep track of these up here. So the two intercepts are going to be negative 1.28 and 0, and then positive 1.08 and 0. Now watch what happens when we find the axis of symmetry, or the x value of the vertex. Negative 1.28 plus 1.08 divided by 2 would give us what? Negative 0.2 over 2, which would give us negative 0.1, like that. Now, if we were to check that with this formula, what's the b value? It's negative 1. So we'd have negative 1 over 2 times the a value of negative 5, which this would be positive 1 over negative 10, which indeed would be negative 0.1. So that's the x value of the vertex. So then we'd have y equals negative 5, negative 0.1 squared minus negative 0.1 plus 7, like that. Right? And so here, this would allow us to find the y value of the vertex. And when you do all that algebra, you'd get approximately 7.05. Right? So those are the coordinates of the vertex, and then also the y-intercept, easy to get, it's 0 and 7. Right? If we plug in 0 for the x's, we'd end up with a y value of 7. So if we plot these, we'd have what? 1.08 and 0, and then over here we'd have negative 1.28 and 0. Then we'd have negative 0.1 and 7.05. That would be like up here. And then we'd have 0 and 7, which would be like right there. And so we end up with a quadratic that looks like that. Notice it's opening downwards because that a value is negative. It makes sense that it would be opening down. Right, so in this case, lots of decimals when we were finding those x-intercepts, but nevertheless, this is what the quadratic would look like. And then finally, part D. So we have this quadratic, finding the x-intercepts. What do? Plug in 0 for y. And so notice we now have a quadratic equation like that, right? The a value is 3, b value is negative 9, the c value would be negative 2, so plugging these in, we'd have negative 9 plus or minus negative 9 squared minus 4 times 3 times negative 2 all over 2 times the a value of positive 3, which would give us 9 plus or minus 81 minus, or no, positive, because the two negatives would make a positive. This would be 24. That would be all over 6 like that. So we'd end up with 9 plus or minus, here we'd end up with 105, like that. And that's going to be over 6. And then this 105, let me think. Yes, it doesn't divide by a rootable number. It won't divide by 4, won't divide by 9, won't divide by 16. won't divide by 25, won't divide by 36, etc., etc. So we can't simplify this radical expression over here. So the two x-intercepts that we would have would be either 9 plus root 105, that would be over 6, or 9 minus root 105, and that would be over 6 like that. And then when you do these calculations over here, you'd get approximately positive 3.21, and then over here you'd get approximately negative 0.21. When you do these in your calculator, those would be the corresponding decimals. So those are the two x-intercepts right there. So we'd have 3.21 and 0, and then negative 0.21, and then 0 like that. So from here, to find the axis of symmetry, we can just add these two and divide by 2, which would be what? 3 over 2, which would be 1.5, like that. And then if we check this with this formula, negative b over 2a, so we'd have negative 9 over 2 times the a value of 3, so we'd have 9 over 6, which indeed would give us 3 over 2, right? Or 1.5. So it makes sense that that we got this. So we could be pretty confident that we're on the right track. Now, for the vertex, I'm actually going to keep this as fractions, this case. So you can use 1.5 if you want when you plug it in here, just in case your teacher expects you to use fractions. Fractions are tougher to work with than decimals, so that's what I'll do. But if you want to just plug in 1.5 for the x values and then get a corresponding decimal for the y value, you could do that. Again, I'm going to keep it as fractions. We did decimals in the other one. This one, let's do fractions. So 3 to the power 2 is 9, 2 to the power 2 is 4, minus 27 over 2, minus 2. So this would be 27 over 4, minus 27 over 2, minus 2. So that would be 27 over 4, minus 54 over 4. Right? If I multiply this by 2, multiply this by 2 to get a common denominator, and then if I multiply this by 4, this by 4 to get a common denominator, we'd have 8 over 4 like that. Then we'd have what? Negative 27, or sorry, 27 minus 54 is negative 27 minus 8, would give us negative 35 over 4 like that. Okay, so that right there would be the y value of the vertex. If you want to get the decimal of that, it's going to be what? Negative 8.75, like that, for the y value of the vertex. So now, enough information to plot it. We could also get the y-intercept, which is going to be 0, negative 2. Right? If we plug in 0 for the x's, we end up with the y value negative 2. The c value in the standard form is always going to be the y-intercept for a quadratic. So, graphing these, we'll have 3.21, let's say that's like over here. Negative 0.21, that's like over here. 3 over 2, negative 35 over 4, so that's like 1.5, and then down here, so this would be 3 over 2, and negative 8.75, or negative 35 over 4. Then we'd have 0, negative 2. Give me a sec here. Am I missing something? No. Yeah, so it looks like that. So we end up with a quadratic that looks like that. Right, so that's the process. The biggest thing was, again, getting more practice with the quadratic formula, and we were using it to find the x-intercept because we plug in 0 for y to do that, and then we end up with a quadratic equation. Different ways to solve a quadratic equation. Sometimes it's going to factor, right, like it did in part A, for example. A lot of times it won't, and if it doesn't, you can use the quadratic formula to solve those equations.